All right, so books should be coming out. The heading for your notes is scientific notation. Conversations should end now. Just a workbook for now. The band reference stuff is in the notes that I gave you last week. Okay, year nines, listening. So let me set the scene. So today I'm going to teach you a convention that is very often used in science and engineering. Some of you will have seen numbers written like this. There'll be a number between 1 and 10, and then it will be multiplied by a power of 10. So that's actually the speed of light in meters per second. These are all very famous numbers that all scientists will know. That's the number of atoms in 12 grams of carbon. Let's see. This is the mass of the Earth in kilograms. Now, this might not mean much to you, but by the end of this lesson, hopefully you'll understand what these numbers mean. Okay? So you don't need to write them down, but that's our goal. We want to understand what these numbers mean and why we're using the number 10 there. So let's build our way there. So you don't need to write down the orange. All right, so let's think back to a couple of weeks ago. What do I get when I raise a number to a power of 0? Harry, 1.
So do we write down the blue stuff?
You might as well. Okay, so I just want a basic numeral or a number. So all the digits. So what's 10 to the 1?
10.
Call it out. Yeah. 10 to the 2?
100.
10 to the 3?
1,000.
1,000. All right, what about 10 to the minus 1? Shannon?
You want to say 1 over 10?
1 over 10 is fine. Today we're going to focus on representing these things with decimals. So we did a unit on fractions, decimals, and percentages last year in year 8. If I want to convert the fraction 1 over 10 to a decimal, what is that going to look like? 0.1. 10 to the minus 2?
0.01.
Yeah. All right, so I want to draw your attention to a couple of things here. 10 to the 3 has 3 zeros, the same as the index, but 10 to the minus 3 has 2 zeros after the decimal point. What's up, Taya? Kind of, but you've got the decimal point as well. Yeah, so just gotta remember that, okay? All right, so when you were in primary school, you probably learned things like thousands and millions, and you probably had a game where you tried to pronounce this really long number, like 597 billion, 493 million, 255,000, 127. It just goes on and on and on, right? So why do we want to use scientific notation? Well, let me give you an example. Let's say I have the number that looks like this. How many zeros are there? 15 zeros. Now, without scientific notation, if I wanted to do a calculation, I would have to write this number in full. If I'm working with 10 numbers this size, It's going to be a mess on the paper. So, is there a way that I can represent this number without having to use all the zeros? And there is. Maybe we can make use of something like this. So, for example, if 10 to the 3 has 3 zeros after the 1, and this number, which is 1 quadrillion, has 15 zeros after it, what do you think the representation is going to be using scientific notation? Let's go, Shannon. 10 to the power of 15. Is that all right? Okay. Let's add another layer to this. Suppose I multiplied the whole number by 8. So now, instead of 1 quadrillion, I've got 8 quadrillion.
I think I've got, I'd say 80 to the power of 15.
Talia and Harry have suggested 8 to the power of 15.
I said 80.
80? Don't write this. We're not quite there yet. Josh? Yeah, so if you know this, so I know Mrs. Evans' class did this last year. It's actually 8 times 10 to the 15. So don't worry about this yet. Just notice that to get from this number here, which is 1, I multiply the whole thing by 8 to get this new number here.
And 8 to the power of 15. 8 by 8 by 8.
So if I have 10 to the 15, and now I want 8 of them, I'm going to multiply the whole thing by 8. Okay? Let's do one more, and by now, hopefully it'll be a bit more obvious. Let's say I have, let's pick 4 quadrillion. So we've still got 15 zeros. What was that, Louis? 4 times 10 to the 15. So it's the same as the first number, but this time we've multiplied the whole thing by 4 rather than 8. Is that okay? All right, what about the bottom number? Now it's 4 million, so there are 6 zeros after the 4. Lockie?
4 times 10 to the power of 6.
Yes. Okay, so at this stage, so aside from the fact that we're using indices, do we sort of agree that this is sort of quicker to write than this?
Yes.
Right? So if I wanted to conceive of a number with 500 zeros, I could just write 10 to the power of 500 in 1 second, rather than writing 500 zeros on the page. I don't want to do that. Okay? So we've introduced scientific notation to make our lives easier. And when you do science, you're going to work with very big numbers, like the mass of the Earth, the mass of the Sun, and very small numbers, like the distance between 2 electrons in an atom. Okay, so I'm now going to describe to you scientific notation, the convention. Yes, please write this down. Here, we write numbers in the following form. So I've got a number A, and then I'm going to multiply it by a power of 10. Now, there are a few restrictions on these numbers. First of all, A is going to be between 1 and 10. So let me explain what that means. So A is between 1 and 10. 1 is included. 10 is excluded. So we're not going to use the number 10 at the front. We're only going to use the number 1, but I can use any number in between. So I can use 9.9, 9.99, 9.999, but I'm not going to use 10. It'll be clear later why I've chosen not to include 10 there.
Isn't it then just adding another L?
Exactly. It's like adding another 0. Okay, so it would be redundant to do that. So A is between 1 and 10, and n is, I'm going to use a mathematical term here. N is an integer. Now, I remember explaining this to my class last year. You might have forgotten, but I'm going to throw it over to last year's 8b and 8c. Do you know what an integer is?
No.
Shannon, what do you think?
Isn't it a whole number that's it's any whole number that isn't 0?
Whole number which isn't 0. Okay.
Positives.
So you wrote it down, Ty? So just wait, Talia, you find it. Josh, what were you going to
An
say?
integer is any whole number that can be negative or positive.
Negative or positive. So do you include 0 in that definition? Okay, so Shannon doesn't think we include 0 either.
Yes.
Can we include 0 as an integer?
It's literally that.
You do. You do include 0 as an integer. Talia, did you write that down last year?
Yeah. If a number is repeatedly multiplied, this can be expressed in base integer. Is that it?
Integer.
Yeah. That's what I add.
All right.
Natural numbers are 0, 1, 2, 3, negative 2, negative 1.
0, 1, 2, 3. Yeah. Okay, so when I say the word integer, I'm saying it's a whole number which is positive, negative, or 0. So 1, 2, and 3 are allowed. Negative 1, negative 2, and negative 3 are allowed. And 0. So I'll just give you 20 seconds to get that down. And then we're going to make some numbers together. All right, if you've got a scientific calculator, I'd like to invite you to find a button that looks like this. It'll have times 10 to the x probably somewhere. No? CAS is different to scientific. So if you've got a calculator, grab it out. And I'll find mine as well on here. Okay, so everyone has a different scientific calculator, but all scientific calculators should have, and this one doesn't have it, great. Hang on, I'll just try to find a different one. Yeah, but there should be one that has just times 10 to the x.
Yeah.
Mine has that.
Yeah.
No, mine has x to the grade.
Okay, this is a very primitive one, but watch this. 5 times 10, and then you can specify the number you want up the top. Oh, sorry. Yeah, it needs to be an integer. I'm getting ahead of myself. So, okay. You did. All right. Thanks, Mr. Mawson. We'll come around and try to get you started.
So do we start on
Okay, so most of you have found the button on your calculator now. So let's investigate what happens when we add some decimal points to the number. So how many zeros are going to be after the 5 in the first one? 4. So 5 times 10 to the 4 is just 50,000. Okay? Yeah, so these are all 5 with a decimal point after it. Okay? Now, I don't have a calculator, but based on my experience, I know what this is going to be. This is going to be 52,000. This is going to be 52,900. This is going to be 52,910. If I add one more, that's an 8 there. Anyone want to guess what this is going to be? 5,200. Yeah. So your first digit at the front is going to determine the first digit here. And if I want to add more, just add more after the decimal point. Okay? But please notice I haven't changed the power. Okay? The power has always been 4. Watch what happens if I change it to 5.2 times 10 to the 3, 5.2 times 10 to the 2, 5.2 times 10 to the 1, and let's go 5.2 times 10 to the 0 as well. All right, so I'm trying to build your intuition here. So let's imagine I just had 5 times 10 to the 3 to start with. 5,000, because there's 3 zeros after it. But now I've added a 2 there. It's 5,200. All right, year nines. I want to draw your attention to something. What's the relationship between 10 to the power of 3 and 10 to the power of 2?
Mine?
No, Sherry, what is it? That sounded like you were on track there.
No, I was just gonna say 2 is below 3.
Okay. So my question was, what's the relationship between 10 to the 3 and 10 to the 2? If I'm here and I want to go here, what do I need to do?
Divide by 10.
Divide by 10, because I'm decreasing the power by 1. Okay? So, most of you will know a shortcut. If I want to divide by 10, what can I do? Remove the 0 or move the decimal points to the left. So now, instead of 5,200, it's going to be 520. And then the next one's going to be 52. The last one's going to be 5.2, because 10 to the power of 0 is just 1. Alright, I'm going to take a poll of the class. You're looking at this right-hand side. I want you to give me a thumbs up if you are following. I want you to give me a middle if you want me to go over it again. And thumbs down if I've just lost you and I'm on a different planet to you. Okay. Thank you. Alright, I think what I'll do is I'll do one more example. I'll let some of you start, and I'll assist those of you who have middle fingers. Not literal middle fingers, but middle thumbs. Sorry, let me do something different. Okay, so on this on the previous page, we went from scientific notation to a number. Now we're going to go backwards now. So if I give you the number, I want to now change it into scientific notation.
Yeah. So you want us to write these answers in scientific notation?
Yeah.
Alright.
Okay.
So we write all those numbers.
These are examples. So I would suggest that you write them down. If you're learning this for the first time, yes, you should definitely write this down. The point is that after I am long gone from your life, you'll have an example to look at.
Always remember you, Mr. Chu.
You're very sweet.
Also, mate, I'm going to die before you.
Okay.
That is my oath. I'm going to die if you
Betting with me?
honor.
Okay. I actually think the whole numbers are easier to start with than the decimal. So why don't we start from the bottom of the left column? How many zeros are after the 3? Yeah, 4 zeros. So what's the scientific notation representation going to be? Let's now move up the page. You should see a pattern emerging probably. Yep, because there are 3 zeros after the 3. Talia, what do you reckon the next one is?
3 times 10 to the power of 2.
Good?
It just goes down.
Yep.
But then when you get to 3, it's just 3 times 10 to the power of 0.
Yes. Because 10 to the 0 is 1. So I'm just saying, it's 3 times 1. It's kind of redundant, but remember I want a power of 10 every time.
And then how do you do decimals? Yeah, is it negative?
It's negative 1. It's 3 tenths.
Oh, yeah,
Okay, so if you've forgotten, 3 tenths is the same as 0.3. 1 tenth is the same as 0.1.
Oh, these are in the room.
How did you do those 3 points?
Good question. Talia has asked an excellent question. What do we do with the 391 now?
391 times 10.
Is it just 3 9?
So you can't have anything over 10.
1 times 10? Or is it. Wait, is it okay? 3.91 times 10 to the power of 2. Is that it?
Okay,
Oh, no.
this is great. This is good for a discussion. So don't write anything yet. Sometimes I'll write the wrong answer to make a point. So, this is where we need to be clear. There are 2 zeros here. So maybe we might think it's going to be 3.91 times 10 to the 2. But now Talia, you think it's 4. Why?
Because it's after the decimal point. Is it 3.9100? So it's 4.
Yeah.
Is it?
10 to the 4.
Yeah.
So think of the 0.91 as modifying the digits after the 3.
Yeah.
So you can only count the zeros when it's only 1 digit. Otherwise, what you have to do is count the number of places between the first digits and the decimal point. So the decimal point will be here, right? After the ones. And can you see that there are 4 digits here? There are 4 digits between 3 and the decimal point. Well, power is going to be 4.
So that means the next one's 10 to the power of 3.
Mm-hmm. Yep.
3.91.
Has anyone played Cookie Clicker by any chance? So Cookie Clicker has an option, long numbers and short numbers. So if you turn on short numbers, it will actually display your cookie counts with scientific notation. Fun fact. No. If you have not played Cookie Clicker, don't play it. It's a complete black hole for your time. I definitely do play Cookie Clicker every now and then. Yes. I'll take a screenshot of my game, okay? Okay, you're 9s. Do you want to have a go now yourself?
Yeah.
All right. If you want some help understanding the last few examples, please put up your hand and Mr. Mawson or myself can come and assist you. Otherwise, have a go at the first few questions of 2E, and then in period 4, we'll talk about significant figures. All right, thank you.